Distant stars are certainly very interesting objects. However, have you ever stopped to think that although the study of the sun seems simple at first glance, in fact we still know very little about it? Hello everyone! For example, recently the cause of rapid temperature variations in the sun has been discovered, revealing similarities between the sun and a microwave oven. So, would you like to know more about this subject? Welcome to our channel. I'm Wikivedia Plus and it's time to start our video. The sun and its layers. First, let's give a brief general explanation. You probably already know, through several sources, that the temperature on the surface of the sun is about 6,000 degrees. This, in general, is correct. However, as usual, here is included a certain nuance. The sun does not have a solid surface like the Earth, and, in general, has a viscous texture. What you recognize as the surface of the sun is the lower layer of the atmosphere called the photosphere. In fact, the temperature of the photosphere reaches 6,000 degrees. However, in other regions of the sun, temperatures vary considerably. The deeper, the hotter it gets, reaching about 15 million degrees in the core of the sun. And what about the outer layer of the sun, above the photosphere? For example, the chromosphere, which is just above the photosphere, is relatively cold, with a temperature of about 4,000 degrees. On the other hand, the solar crown, the outermost layer, is extremely hot, with temperatures above 1 million degrees. Until recently, we did not understand why the solar crown was so hot. In addition, even being part of the same layer, it was unknown why areas of exceptionally high temperature emerged regularly, standing out from the environment. It seems to be related to solar eruptions that occur periodically, but what would be the exact cause? So far, no answers have been found to this problem. It is worth noting here that studying the sun is actually extremely difficult. The sun seems to be hanging directly above our heads, so why is it so difficult to study it? Unfortunately, we cannot gain more knowledge through observations of the Earth. The overall structure of the sun, its chemical composition and patterns of brightness variation have been investigated for a long time. However, with all this knowledge, it is still not possible to answer the problem mentioned above. To find answers, it is necessary to send probes to the sun, but this is a considerable challenge due to the laws of celestial mechanics. Fortunately, despite many challenges and difficulties, we were able to send several probes to the sun. Among them, the Solar Orbiter, launched in 2020, was the probe that got closest to the sun. Thanks to the powerful modern observation instruments embedded in this probe, now we can investigate the sun in details that we did not have access to before. And in fact, apparently thanks to this probe, we were able to unravel why the regions of the highest temperature present in the solar crown and on the surface of the sun are so intensely heated. Magnetic field and similarity between the sun and a microwave oven. Just like the Earth, the sun has its own magnetic field. The Earth's magnetic field is generated by the circulation of electric currents in the liquid external nucleus, while the sun's magnetic field is generated by plasma circulation in the convection zone, located between the nucleus and the troposphere. This plasma has an enormous mass, making the sun's magnetic field extremely powerful. The sun's magnetic field is incomparably stronger than that of any other planet. In addition, the sun's magnetic field changes surprisingly. The configuration of the magnetic lines that make up the sun's magnetic field changes frequently. These magnetic lines are constantly moving, separating and reconnecting. Due to the influence of the magnetic field, changes in the configuration of matter in the sun cause a variety of interesting phenomena. In addition, the sun is significantly heated by the magnetic field. This occurs due to the same principle as microwave ovens. Matter in the sun is heated mainly by thermonuclear reactions inside it, but we must not underestimate the role of the magnetic field. Scientists have long discovered that the reconfiguration of magnetic lines occurs more intensely in the upper atmosphere of the sun. These magnetic lines bend, intertwine and separate, attracting large amounts of matter. This results in the formation of proeminences and bright solar eruptions that can be observed on Earth. However, until recently, we did not know exactly what caused the temperature variations in the atmosphere of the Sun and why the solar crown is heated that way. So far, we have only been able to observe magnetic reconnections, that is, the recombination of magnetic field lines on a large scale. Although the turbulence of the magnetic field is intense, this energy is not enough to generate such a drastic increase in temperature. That's when the hypothesis arose that smaller but constant magnetic reconnections may be occurring more intensely than those on a large scale. However, until recently, this hypothesis had not been confirmed. Small scale and high temperature. That's when the solar orbiter we mentioned earlier was essential to help scientists. Thanks to the powerful instruments embedded in this probe, along with the probe's ability to get very close to the Sun, we were finally able to visualize the magnetic field lines on a small scale in the solar magnetosphere. And as scientists had predicted, we found that the magnetosphere is subject to intense turbulence. By means of the instruments embedded in the most recent probes, we were able to successfully discover the 0 points, in which the intensity of the magnetic field reaches almost zero. In fact, the reconnection and change of magnetic field lines occur exactly at these 0 points. Each of these magnetic field lines seems to be attracting the material of higher temperatures inside the Sun towards the photosphere, and this material is even warmer. Do you remember the microwave oven effect? This is why the temperature at 0 points can reach 10 million degrees. In addition, the only other region where this temperature is reached is in the parts of the solar system. The only other region where this temperature is reached is in the deepest parts of the Sun, but even so, the conditions in these regions are slightly different. Especially because the pressure is much higher in the deepest parts than in the photosphere. The superheated matter of the Sun cannot be contained and ends up exploding towards the upper atmosphere of the Sun. It seems that the cause of the intense heating of the solar crown is hidden here. In other words, the solar crown contains material that passed through the oven called point zero. The irregular temperature distribution in the photosphere can also be attributed to the same reason. However, the mysteries have not yet been completely unraveled. Specifically, we still do not know why the magnetic field of the Sun behaves this way and why the 0 points are formed. As mentioned earlier, the formation of the solar magnetosphere is attributed to the convection zone, but we know very little about it. What we know is that the convection zone is composed of many hexagonal cells, and in the center of each cell, the heated material rises from the interior of the Sun, while at the edges of the cells, the colder material descends from the outer layer towards the nucleus. It is natural that it is very difficult to study the convection zone. Under these conditions, no probe made with the materials known to humanity would be able to resist. Therefore, we currently have to rely on indirect research results. Well folks, and so we come to the end of our video today. Thank you all for watching. I hope you enjoyed our content. In short, we have an optimistic view that we will certainly find a solution. Even if we cannot penetrate the Earth's crust, we can investigate the mantle and the nucleus in great detail. Therefore, it is not necessarily necessary to dive into the Sun to study its interior, since we can use modern equipment. In other words, many surprising discoveries are waiting for us in the future. And if you can help in the development of this project, leave a like and share the video on your social networks. Well, it's time for us to say goodbye here. A big hug and see you soon here on the Wikivedia Plus channel.